Okay, today we will be looking at the final lesson in Chapter 5, Lesson 8, which is on factoring algebraic expressions. Okay, today we will be looking at the final lesson of Chapter 5, Lesson 8, which is on factoring linear expressions. Before we can start factoring linear expressions, we need to go over a few vocabulary words that are appearing on page 416. Here it says a monomial is a number, a variable, or a product of a number and one or more variables. So the number 25 is considered a monomial. The variable x is considered a monomial. But also when you have a coefficient variable combination like 40x, that is also considered a monomial because those things stand alone. Over here on the right-hand side where it says not monomials, what we have is called polynomials. Polynomials are a combination of two or more monomials. So x, a variable by itself, would be a monomial. Plus 4 by itself would be a monomial. But you put them together, you have a polynomial. So x plus 4 is a polynomial. 40x plus 120 is also a polynomial. To factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. So the greatest common factor of two monomials is the greatest monomial that is a factor of both. And that's what we're going to be looking for today, the greatest common factor of two or more monomials. So let's take a look at some examples of how to factor out monomials. So here we have the monomials 4x and 12x. To factor these out, I would go and I would list out all the factors of the smallest of the two monomials. So 4x is the smallest of the two monomials. What are the factors of 4? They are 1, 2, and 4. In addition, there is x, which is a factor of 4x. Then I would ask myself, if I'm working backwards, are there any letters that appear with my smallest monomial that also appear in my larger one? And the answer is yes. X is both a factor of 4x and 12x. So x is going to be part of my greatest common factor since it is a part of both monomials. Then I would also look at my numbers going backwards. 4 is the largest factor of 4x. Also, I'm going to ask myself, does 4 divide into 12? And yes, 4 does divide into 12. So my largest factor of 4x is also a factor of 12x. Therefore, the greatest common factor of 4x and 12x is 4x. Let's take a look at another one. 18a and 20ab. What are the numbers that divide equally into 18? Well, they are 1, 2, 3, 6, 9, and 18. In addition, you will see the letter A, which I'm going to list over here as well. Then I'm going to ask myself, are there any common letters? Well, is A a part of 20AB? And yes, it is. A is a part of 20AB, so A will be part of my greatest common factor. Then I'm going to look at my numbers, and I'm going to ask, starting from the right, does 18 divide into 20 equally? No, it doesn't. 18 is not a greatest common factor. Does 9 divide into 20? No. Does 6 divide equally into 20? No. Does 3 divide equally into 20? No. But when I get to 2, 2 does divide equally into 20. Therefore, my greatest common factor will be 2 and A, since A appears in both. Let's look at one more problem here. We have 12 CD and 36 CD. If I list out the factors of 12 CD. I'm going to find 1, 2, 3, 4, 6, and 12 divide equally into 12. In addition, I have two letters, C and D. Like before, I'm going to ask, do those letters, C and D, either one of them appear with 36 CD? And they both do. So C and D are both going to be part of my greatest common factor. Now, let's see if we can figure out which number up here it's going to be. And I'm going to ask myself, starting with the right side, does 12 divide into 36? Yes, it does. I know that 3 times 12 is 36. Therefore, 12 is my greatest common factor of both 12 and 36. And so I will put it down here with the CD, and my greatest common factor is 12 CD. Why don't you try to do letters A, B, C on your own? Watch out for letter C. 42 is tricky. It's got lots of factors, so be very careful with that one. Now that you've had an opportunity to practice A, B, and C, let's move on and take a look at factoring linear expressions. It says you can use the distributive property and work backwards strategy to express a linear expression as a product of two factors. A linear expression is in factored form when it is expressed as the product of its factors. So that's a lot of words and a lot of wordiness there. Basically, what it means is we're going to use what we know about the distributive property to undistribute or work backwards. We're going to undistribute this problem. So take a look at 8x and 4y and ask yourself, what is the greatest common factor of 8x and 4y? What is the largest number that will go into both of them? Hopefully, you can see that 8 and 4 are both divisible by 4. I'm going to make an upside down division symbol, and I'm going to put in the number 4 as the number I'm going to divide into both 8x and 4y. 4 goes into 8x 2 times, so I'm left with 2x. 4 goes into 4 one time, so I'm left with just 1y, which I would only write y. I don't put 1 next to it. So now there is not a number that goes equally into 2x or into y. So I'm going to put that inside parentheses, and then I'm going to drop my 4 down outside of the parentheses. That gives you 4 times 2x plus y in parentheses. Earlier in this chapter, when we saw this situation, we said, oh, you need to distribute the 4 that's outside the parentheses to what is inside the parentheses. Well, you can see what we have actually done now is undid that. So we've taken the 8x plus 4y and undistributed. We took the 4 out of it, which means we can actually check our answer to see if we're right. So which means we can actually check our answer to see if we are right. This is our answer, but we can check it. 4 times 2 equals 8. So 4 times 2x is 8x. And 4 times y would be 4y. When we distribute the 4, we end up back where we started from, which means this factored form, 4 times 2x plus y, is the correct answer. Let's take a look at another example. Example number 4. 3x plus 9. If we ask ourselves, what is the largest number that goes equally into 3 and 9, hopefully you would say 3. 3 goes into 3x 1x times, so we would just write x. 3 goes into 9 3 times. What did we divide 3x plus 9 by? to get x plus 3, we divided it by 3, so we're going to drop that down as our factor outside the parentheses. So we end up with 3x plus 3. We can again check to make sure we're right by distributing. 3 times x equals 3x, and 3 times 3 equals 9. So again, we can check our work, but our answer that we're looking for is the one that's here in the box, the factored form. The factored form. Take a look at example number 5. It says factor 12x plus 7y. If we take a look at these two monomials, 12x and 7y, and ask ourselves, what is the largest thing that will divide equally into both of them? Well, 7 is a prime number, and x and y are different variables. So what I'm seeing is that the largest number that goes equally into 12 and 7 is 1. If you have a situation where your monomials can only be divided by 1, what you have is something that cannot be factored. So we would write for our answer, cannot be factored. Why don't you go ahead and give letters D, E, and F a try? And then we will go over the word problem. Hopefully you were successful going over D, E, and F. Let's take a look at this word problem that appears on the top of page 418. It says the drawing of the garden at the right has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. Well, we know we find area of a rectangle like the one at the right by taking length times width. So what we're actually asking when we say find the possible dimensions of the garden is we're looking for two numbers or two expressions that when multiplied together would give you 15x plus 18. So we're saying the area is 15x plus 18. What can we divide into that in order to factor that out into two factors? Well, this is just like what we were doing in the previous examples. What number will go equally into 15x and 18? 3 goes equally into 15 and 18. 3 goes into 15x 5x times. And 3 goes into positive 18 positive 6 times. So when we divide by 3, we get 5x plus 6. That is factored down to its lowest terms. And then I would just drop the 3 down outside. So I ended up with a factored expression of 3 times 5x plus 6. So what are the possible dimensions of my garden? We could say that 3 feet by 5x plus 6 feet. Well, now I think we are ready to head on to the guided practice that we will do together in class.